Well, hello folks. Welcome to a little corner of the internet called Marshable Math. My name is Mr. Marsh. Today we're going to be talking about slope. So if you will, please get yourself a pencil, some graph paper, a straight edge so that you can draw a straight line, and let's dig in. Alright, slope, in my opinion, is the most important topic in all of high school mathematics. Find it in Algebra 1, find it in Algebra 2. It's in geometry a bit, but definitely when you get to calculus, slope is fantastic. In fact, I like slope so much, I took a textbook and ripped a page out and had it framed here because it's got all the good stuff all on one page. And I display it in a very special spot in my classroom. If you stop by my classroom sometime, take a look for it. I think you'll like it. Alright, so let's do a bit of review here. Slope oftentimes involves the idea of a Cartesian coordinate plane where we have x values and y values. You've probably seen this before. Let's remember that a location on this space is given by what's called an ordered pair. It would be the x value first, then the y value with parentheses around them. The location of this one in space is 3, -2 because it is 3 units to the right on the x and then 2 units down on the y. And let's see here. Let's talk first about what the definition of slope is. Slope at its essence is just simply a rate of change. It's a comparison between how two things are changing. So it's a ratio or a fraction of the change in one value to the change in another value. So a very common understanding of slope is given by this illustration here. Speed limit, 55, say 55 what? That would be 55 miles per hour. So if I were to write that, it would be 55 miles per, because remember per means division, per hour. How many hours? Well, just one. So a speed limit of 55 miles per hour means 55 miles per 1 hour as a ratio. Now, think about this. It doesn't mean that you've actually gone 55 miles, nor does it mean that you've actually been traveling for an hour. It's simply telling you a ratio of how the distance is changing with respect to how the time is changing. So if you're going 55 miles an hour in an individual instant, doesn't mean that you will eventually go 55 miles, nor does it mean that you have to travel for an hour. It's simply a ratio of how the things are changing. And I have to admit, me, like Sammy Hagar, I can't drive 55. Sorry about that. Alright, another way that you'll see a slope is if you go to the supermarket and you have to make very important decisions like which box of Cheerios is the better buy. You need to be looking for something that's called the unit rate. So if you look down on the little price tag down there below where the item's displayed, you'll see something like 2.35 cents per ounce. What does that mean? Well, 0.023 cents, which if you express it in dollars would look like that, per ounce. How many ounces? Well, per 1 ounce. It's telling you the price for a single unit of measure. This is a 12-ounce box. Maybe you could run the math there and find out how much this box would cost. But if you're comparing the prices, man, the prices themselves don't really compare that much to you. The size of the boxes themselves don't mean a whole lot. It's when you compare how the price changes with respect to how the ounces change, that's what you're looking for. You're looking for the unit rate. I'll just save these for lunch. So now let's take a look at the formula, because maybe you've seen slope before with regard to a Cartesian coordinate grid, and you know that there's a formula involved. The formula for slope would look like this. Slope is equal to the second y value minus the first y value divided by the second x value minus the first x value. And all these things are simply your x and y values of 2 points on the graph. Please note though, these are not exponents. It's not y squared minus y to the first divided by x squared minus x to the first. Notice these are superscripts. Superscripts means exponents. This is a subscript that's written below the line, and it's simply a name that basically tells you how to keep one point straight from another. This is the first y value, that's the first x value. That's the second y value, that's the second x value. So understand it that way. Maybe you've seen it like this before too. Maybe you've seen it like slope is equal to the change in y divided by the change in x. We use the triangle here to denote change. Notice again, it doesn't mean what the x and y values are. It means how we're changing them. Okay? So just like 55 miles per hour didn't mean that you had to drive 55 miles nor drive an hour, so the slope here in terms of x and y doesn't mean what x and y are. It means how you change from one x value to the next value, or how you change from one y value to the next y value. Maybe you've also seen it like this before. Some people say it's something like rise over run. And that's just a little shorthand way of helping you remember that you're talking about what's going on up and down first, and then on the bottom you're talking about side and side. One of the things that people do when they make mistakes is, because this I think is written as an x first and then a y value, you get in that habit of x first, then y. Notice this one's different. It's the y value on top, and then it's the x value on bottom. A common mistake is to put the x value on top, but that's not the case. All right, so now let's talk about slope of a line from a graph. So take a look over here at these lines. Let's look at the blue one first. Remember, slope is the change in the y value compared to the change in the x value. It tells you how to get kind of from point to point. So let's look at these locations right here. If I take this location here in space, how do I get from this location to this next location, this next point? And I've picked easy points here where they cross the coordinate grid, so it'll be simple to work with. Well, if the slope is the change in the y value divided by the change in the x value, all I have to really do then is count how far I go up or down and how far I go left or right. So how do I get from this location to the next location? Well, I go up 1 unit. So that's a change of positive 1. Divided by, how do I move now left or right? Well, I move to the right 3 units. So that's positive 3. So the slope in this case is 1/3. Commonly, we don't write the plus sign, but I wanted to put it there just to help you understand that the direction is given by the sign, right? If we go down on the y, it would be a negative. If we go to the left on the x, it would also be a negative. So this slope here, the blue line, has slope of 1/3. It means every time I move, I go up the ratio of 1 y unit to 3 x units. So I could do that to find the next point too, right? Go up 1, right 3, hey, there's my next point. Okay? So it tells you how to get the change in one value compared to the change in the other value. What about the red one? Switch sides over here. What about the red slope? Slope again is equal to the change in the y value divided by the change in the x value. I'm going to pick 2 easy points on here, this one and this one. How do I get from this location to this location in space? Well, let's do the up and down first. I go up 1, 2, 3 units. So that's a change of 3. And then how do I go left and right? It's 1, 2, 3, 4. It's 4 to the right. So the slope for the red line is 3/4. Notice that I'm not telling you that I'm at 3 or at 4. It's simply telling you how the things are changing. Notice too, this red line here seems to be a bit steeper, right, than the blue line. We can tell that just by looking at them, but we can also compare the quantitative values of the slopes. 1/3 to 3/4. Which one is a bigger value? Which one has a larger magnitude? Well, the 3/4 has a larger magnitude, okay? So the size of the slope actually tells you the steepness of it. Now, also, both of these turned out to be positive. This is positive 1/3. This is positive 3/4. That means that as I move from left to right, my y value is increasing. Positive means an increase. So it means I'm rising as I go from right to left. But what about that green line? Well, let's take a look at his slope here. Again, I've picked some easy points. Slope then is equal to, oops, we'll get to m later, change in y over change in x. How do I go from this location to that location? Well, now I'm going down 2 units, so that's a negative 2. And then I go to the right 3 units. So what I've got here in terms of my slope is I've got down to right 3 units. So this is actually a negative slope. If the slope is going down with regards to the y, if the y is decreasing as you move from left to right, you've got a negative slope. Positive slope, negative slope, you can get that just by looking at the pictures. When you do the actual math, the sign itself will tell you the direction. But notice that I didn't have to start with the left-hand point and move to the right-hand point. What if I take this point right here? And I work to this location. Well, what is that slope? If I start here, how do I go to this point there? I would go actually up 2 units, so that's positive 2. Up to here, and then I would go to the left 3 units. but left is negative on the x. It's a change of a negative change, so it's going to be negative 3. Is there any algebraic or numerical difference between these two ideas? They're actually the same. All right, so it doesn't matter which direction that you go when you're moving from point to point, so long as you understand that left and right then would be positive and negative, up and down would be positive and negative. So if you keep the direction straight, you should be able to work it out. All right, now let's talk about how we would do things analytically. What if I gave you 2 points and asked you to find the slope between them? We would use this formula here. Let's see here. Let me just try these two right here. What's this location? Is this not the point 2, 2? Oops, right, 3. 2, 2, over 2, up 2. That's this location. This one right here would be 1, 2, 3, 4, 5. This would be 5 for the x, and it would be 1, 2, 3 for the y. So if I've got the points now that are 2, 2, does that address the ballerina wears? And then I've also got the next point 5, 3. How would we do this analytically? How would we do it without the graph? Okay. Well, we got to identify a first point and a second point. Usually I go from left to right. So I'll call this one the first one. I'll call this one the second one. All right. So now let me use my formula here. I've got the second y value, which is 3, minus the first y value, which is 2. Now I'm going to divide that by the second x value, which is 2, minus the first x value, which is 5. Okay? And no, stop. Hold the phone. I goofed that up, did I not? Second x is 5. It's important to keep these things straight. Minus the first x value, 2. Whew! Don't make that mistake. If you pick a direction, doesn't matter which one's first or second, but once you pick one as first and second, it's got to be consistent for both the y values and the x values. Don't go mixing them up. So 3 minus 2, what's that? 1. 5 minus 2, 3. Is it the same thing? You bet it is. Okay? Now, I want you to try one, so get ready to stop the tape. Let me have you do one when the x value is, your points are negative 4, 2, and the second one is 2, 10. So take a moment here and try your own skill analytically solving for the slope. Okay? Go ahead and press pause. I'll be back to you in a second. Okay? Well, let's try it. I usually pick the one on the left as the first point, one on the right as the second point. So what's my second y value? That would be 10. Minus is part of the formula now, minus the first y value, which is 2. Divided by, what's the second x value now? 2. But now be careful. Watch this. I have a negative as part of the formula, but now I've got a negative as part of the number itself. So it's minus a negative 4. Okay? Let me simplify. 10 minus 2, that would be 8. 2 minus a negative 4. What would that be? Doesn't this make it a positive? So that would be 8 over 6. And then if I reduce the fraction, I get what? Divide both by 2? 4 over 3, 4/3. Is that the slope? We can check ourselves by plotting the points and taking a look. Let's find out. Okay, negative 4, 2. That would be the x first. Negative 4, 1, 2, 3, 4, up 2. That's the location there. And then 2, 10. That would be this location here. 1, 2, 6, 7, 8, 9, 10. Okay, I'm going to draw my line now. Point down, straight edge on the point, angle it so it goes through. There we go, something like that. Okay, what does this mean? This means I go up 4 and then right 3. So up 4, 1, 2, 3, 4, right, 1, 2, 3. Oh, nailed it. Up 4, 1, 2, 3, 4, right 3, 1, 2, 3. Got it. if you want to play with it, try this one. Isn't this algebraically equivalent to -4 and -3? If you could try that and see if you went down 4, left 3, if you'd actually wind up with the same value. Okay, good job. Now, let's try one other one. We've got the slope formula. What if I did, what if I asked you a question like this? What if I give you a point? You may say, what's the point? Good question. I'll tell you. Okay. If I give you the point, say 3, 1, and I ask you to draw a line through that point with slope, let's say, is equal to 5/6. How would we do that? First, let's plot the point. 3, 1, 1, 2, 3, up 1, here we go. And then how do we find where the next point is? Notice it's not 5, 6. People confuse this and say, oh, it's 5 and 6, right? So that would be 1, 2, 3, 4, 5, up, 1, 2, 3, 4, 5, 6. No, something like that there. That's wrong, okay? This isn't the values, remember? It's the change in the values. So, not starting from the origin here, but starting from the point that was our beginning, I'm going to go up 5 and right 6. That's not this location. That's up 1, 2, 3, 4, 5, and then right 6. 1, 2, 3, 4, 5, 6. That'll be that location there, okay? Don't need this piece. That's how I would draw a line. Through the point 3, 1 with a slope of 5, 6. Point down, straight edge against the point, angle it such that it goes through, draw your line. Probably going to put arrows on those to show that it goes on forever. Okay, one more. Let's have you do one. Let's have you do one that would be the 0.15, and I want you to have a slope of -4/3. Okay, go ahead and press pause on the tape and give that a shot, see what you get. Blue. All right, 1, 5. 1 and then up 1, 2, 3, 4, 5. Location there. And how do I get to the next one? If I wrote it as -4 over +3, the negative means down, and the y value is what's on top, the change in the y. So that means it go down 4 units. 1, 2, 3, 4. And then the positive here means it go right 3 units. 1, 2, 3. It would be this location here. But just for giggles, what if I said, I don't like the negative there. You put it here. Provided that there's only one negative sign, doesn't matter if you put it on top or if you put it on bottom. So what if I went up 4? 1, 2, 3, 4, and then left 3. 1, 2. Bingo! Okay, good. Next time I'll probably talk about how we do slopes and equations of lines and so forth. But if you got the essence of what slope is, slope being a rate of change, it tells you how one value changes with respect to how another value changes, and we write it as a fraction. Change in y on top, change in x on bottom. I think you're good to go. Okay? Have a great day.